Hello? Hello? Yay! Good afternoon. Thank you very much for being here. I'm going to try to be at least at the expectation of the new revolution. Who was this morning for Fabian's keynote? Yes. Nice. So you basically seen like most of it. So we are going to talk about this new component, Messenger, which is about like buses, message buses, transport, all these kind of things. First, very quickly, I'm going to introduce myself. My name is Roze. I'm working for a small startup whose mission is to increase the elderly's life, based in London. We are hiring as everybody. I am involved in multiple open source communities, obviously the first one being Symfony as a core team member, but also Continuous Pipe with an interesting continuous deployment pipeline if you're into Docker, Kubernetes, and these kind of things. And Tolerance with a fault tolerance library, so you should check this out. The talk is going to be around what are the main concepts in the Messenger component, and then, based on a simple example, how you can actually use it. And then what are the sort of like special things and interesting feature in the component that you can use. So the first thing being, what is it about? So it's about messages. So you are going to create messages and send them to a bus. There's no restriction on what a message is about. It's just your PHP class. There's no abstract class. There's no interface. It's just your own domain message. You dispatch this message into a bus. And the bus is responsible for actually doing the rest, as in calling the other things which are these handlers. So this is basically the third sort of like concept, that's just message handler. That's something that is going to execute your business logic. Not related to the bus necessarily, something that's going to say, I don't know, if you've got a message that you send which is something like send notification, you want to send an email, or an email is a great example. You actually want to send an email, then the handler is just something that is going to do whatever you want to achieve. I've seen a few messages on the Slack, on the Symfony Slack, a few days ago, where the point was to say Symfony Messenger is actually only interesting if it's asynchronous work. Actually, that's completely not true. These three concepts, just themselves, is very, very powerful. If you've heard about CQRS or Common Query Responsibility Segregation, or just a way you can actually structure or organize your application, that's already super useful. Turns out that we decided to say, hey, we're just missing something in Symfony. There's all these worker or synchronous or queues things that we don't have. So the idea was to say, on top of this concept, we were going to add something to which we can send and receive messages. So basically, these are the transports. Wow, that was a bit too fast. The transports are a sort of an abstraction layer to RabbitMq or to an API or a file system, whatever. It's somewhere where you send messages to and somewhere from which you receive images. And obviously, if you've got transport, the last sort of concept being the worker, it is that thing that you're going to run somewhere that is going to be responsible of like saying to the transport, hey, I want some messages. That's basically it. The same thing as a sort of like whoever is more visual, you've got a message and you dispatch into a message bus. Behind this message bus, for this given message, you can have 0, 1, or n message handlers. Turns out that if you want to, you can actually configure the message to, instead of directly calling the handler, you can say, hey, I want to route this message to something else. And that's the transport. These transports, I mentioned, responsible of talking to any single third-party or infrastructure-related things. And then we're going to have our lovely worker that receives some messages from the transport and dispatch them to the message bus. That's it. So, when I'm clicking, that just like goes 2 slides. I don't know why. So what we're going to do is to go through code examples of how you and the developer on the sort of like user learn perspective, you can actually create your messages, create your handlers, and use them. So the first example is going to be a simple message. For example, send notification. So you want to say your application wants to send a notification, regardless of how, with a given message to a set of users. You can see there's nothing specific to the Messenger component. Now, what you're going to have to do is to say, oh, I want to put this message somewhere, so you're going to have to install Messenger, the Messenger component. If you are using it as a component, so outside of like the Symfony, the framework application itself, you can do composer require Symfony/Messenger, and you're going to get the component. If you are using the framework bundle, and if it means you're using Flex now, composer require Messenger will do it for you. That's a component. So you can use it just as a set of PHP classes. This is the only slide where we're actually going to see how we instantiate it as a component, but it's really important that you don't need to be in the framework bundle sort of like context. So how it works. You can see that the first thing being the handler. I'm going to create an handler that handles the send notification messages. An handler is just, again, nothing related necessarily with the Messenger component. It's just a PHP callable. That's it. So here it can be an anonymous function. And the way you're going to create your message bus is by creating a new instance of the message bus, but giving it a set of things. These things are the middlewares. So the message bus itself is probably 40 lines. If you remove the comments, it's very likely to be 10 lines, I think. There's nothing inside. The whole logic and the whole behavior is actually coming from all the middlewares. The basic middleware is the one that's going to take the message and call the actual handler. And his name or its name is handle message middleware. And you can see here that you configure that for every send notification message, it is going to call this handler. As simple as that. The idea is to have the API very simple. Turns out that actually most of you won't never use that. Because you're going to use the Symfony Messenger inside a Symfony application, everything is configured for you. So by default, when you install the Messenger component, you're going to have a message bus automatically created and wired that you can already use and dispatch messages to. We're going to take the example of this send notification message. I'm going to say that's our amazing controller, and it does a bunch of great things. It returns a response which contains OK, and also dispatch a message. So these lines are the important ones. We are going to be able to inject the message bus interface into our controller or anywhere, and dispatch the actual send notification object into our bus. And that's it. I mean, you've seen that this morning already. Now, if we actually just run this code, so it says, yeah, there is no handler for that message. So by default, you need to have an handler for every single message you dispatch. That's by default, so you can actually tweak that using your custom middlewares. But it's really quite like it helps to not do typos and things like that. It also invites you to create the handler. And how you're going to create the handler, you're going to create a function. Problem is that functions in our sort of like a Symfony in the framework world, that doesn't really work. So what we're going to do is to create a PHP callable as a class. So there's this beautiful magic __ invoke method that we can create on objects, on classes, that when you've got an instance of this class, it is actually PHP callable. That's the reason why we've got this invoke method. And the only thing that's going to happen is going to take the message. It's going to take the message as the argument, and that's it. And you can do your own custom logic. Once you've created the handler, you need to register it. So the first thing, we used to do that all the time. You just create a service, and you put a tag, messenger.message handler. Then it will tell to Messenger, hey, I've got a handler. Go into watch. It's kind of like going to do a bit of reflection, look at the type int of the actual invoke method and wire that thing automatically. Turns out it's not really, really convenient to do that for every single of the handlers. So there's a second option. The second option is to use the PSA4 locator. So that's something that the documentation is not necessarily like the biggest for this kind of thing that we've got in the dependency injection container. But you can do that. You can actually say every single class in my message handler folder is going to be actually a message handler. Therefore, you can directly add the tag messenger.messagehandler. And that's it. And we can do even simpler. There's actually an option 3. And the reason I've mentioned these two others is just to highlight there's no magic. The option 3 is to actually use the message handler interface. If you look at it, there is nothing inside. There is 0, no method in the interface. It is just a marker for this new stuff that we've called auto configuration that automatically, based on the different interfaces or potentially parent classes, will say, oh, I know that this is this kind of thing, typically the commons, and I will automatically add the symfony.command tag. Same thing happens here. Message handler interface is just a marker. If you just do that, put that somewhere, it will therefore be auto-configured and auto-wired, and you can directly have something that happens when you dispatch the send notification message. So if we run it, that's basically what it looks like. Yay! So you can see this lovely, you've got a profiler component or a profiler tab as well for like all the messages, so you can debug exactly what happened, what's the result, all of that. And that's basically it. We're done. On the user perspective, the idea is literally I create my object, which is my message, and then I create my handler, and I'm done. That's it. If you create multiple handlers, all these multiple handlers are going to be cool as well. If you create none of them, it's going to tell you no. So that is exactly what we've used in terms of like what in the schema. And it is already, and that's a really important point, that is already extremely important, extremely interesting and useful. Now, for the sake of the demonstration, we're going to believe that actually this echo something, actually it's calling an API and it takes ages to run. Because actually we are trying to send notification to 50 users, and each of the notification is taking, I don't know, half a second. It starts to be super, super slow, right? So if that happens, that is going to look like this. Wow. That's very slow. So here that's an example where I send actually notifications to 50 users, and there is something weird that happened. It takes like roughly a minute. You've got multiple options to how you're going to tackle that. The first one might be just, yeah, it's fine. In which case, you're lucky. And the other one is to say, well, actually, we don't need to send these notifications right now. We can actually send them in a few seconds or like a few minutes. We don't really care. And I suggest we explore that path. So we are going to try to configure the message bus, not to call this handler right now, but to actually call it later. So, and the way we are going to do that is to route this message to a queue system, basically. Something that's going to be asynchronous. So before, what is a transport? So that's the fourth concept that I introduced at the beginning. A transport is just something that has a sender and a receiver. I won't read you the description, that's fairly obvious. Then it is configurable via DSM. That's the idea that Fabian borrowed as well for his mailer transport. But the main concept is the same idea we've done for the doctrine configuration that now is a database URL, which is fantastic because it allows you to run an SQL-like database on your development, but potentially uses Postgres or something else on your different branches or production. The idea is the same thing. We can actually have the entire configuration of where we push the messages or get the messages from in a simple DSN or simple string. And the last point is that it uses a messenger serializer. So when we actually start to go asynchronous, it means that we are going to have to put the message somewhere and somehow, in some format. So it uses a serializer to serialize that message and deserialize it. By default, you don't have to do anything. You don't have to care about it. It uses Symfony serializer, which is now pretty amazing at guessing the right types and the right properties and all of that. So you should have nothing to do. But it's important to know that all your objects and things are going to be serialized if you use the asynchronous bit. Obviously, you can also replace as you wish. If you want to serialize using, I don't know, something else, you can. The way we're going to create a transport, before routing the message to a transport, we're going to just create one. And the way we create one is by adding a new item in the framework.messenger.transports configuration. And here we just name it default, but that's just the name. That's the name of the transport we want to give. There's no magic thing about the default transport or anything, it's just its name. And its configuration comes from, as I mentioned, from the messenger DSN environment variable. If you really want, you can put the DSN directly here, but it's not the greatest thing. And then in your .env file, you can define a DSN. That specific DSN is going to say to the messenger component, create a transport named default that is going to be used to use the MQP transport and all these technical details. That's it. Once we've created the transport, we just rerun the page and nothing changes. It's still super slow. Because the missing bit is that we need to explicitly route each message to the given transport. So now we're going to say, in the framework.messenger.routing configuration, we're going to say the send notification message needs to be routed through the default transport. And that's it. So that's explicit. Obviously, that works for directly the class name, but also its parent classes if you have some, or an interface. Right? And then if we run it again, wow, super fast. But I didn't receive anything. It just put something in a message somewhere, but I didn't receive any notification. So that's where the fifth concept just comes in, and that's the worker bit. Wow. Where you've got a command that comes directly with your Symfony application, which is bin console, messenger consume messages. And that we actually talk to the transport saying, hey, let me know when you receive something. And that worker will actually get the message, deserialize it, and push it back to the message bus, and then call your handler. If you actually run it, that looks something like that. We are going to have our echo, or whatever needs to happen in here. That is where and when these things are going to happen. And that's it. So that's a very short talk, because it's very related to the developer experience. The idea really is to say you've got almost nothing to say, almost nothing to do. You can start with very synchronous, because it's always better to run things as quickly as possible. But at some point, if it starts to be a bottleneck, the only thing you need to tweak is just route the message somewhere, and you're done. There are a couple of other things that you can actually play with. First thing being, what if actually you are into this world of like DDD and you want to separate your different type of messages because some of them are commands and some of them are events and some of them are queries and all of that, which I really appreciate. It's important to do, but you don't have to. So you can create multiple buses. So you can actually dispatch messages into different buses that are going to do different things, potentially. The way you create multiple buses is with that configuration. The main thing is here, buses, so framework.messenger.buses. And then you choose a name. You give it a name for the buses you want to create. And that's the default configuration, just null. The name of the bus is actually going to be the service name that is going to be created by Symfony for you. So if you want to inject one of the bus, you can actually inject using the service event bus or the service command bus in that example. But Symfony, I think it's from 4.3.4. Very recently, there's all this like auto wiring. And the example before I showed you, you actually type in the message bus interface. And if you've got multiple buses, which one actually needs to be injected? So to solve this problem, one bit of solving this problem is to say you need to have a default bus. That is the bus that is going to be injected if you type in the message bus interface and you don't do anything else. That's this bus that you're going to get. Now, if you actually want to inject your event bus somewhere, either you can manually define your service with explicitly giving the right message bus name, or you can hijack a little bit the DI. So that's the hijacking trick. So that is what you have in your config.services.yaml. And I've kept these 3 lines just to remind everybody that all this auto-wiring, auto-configuration, you've explicitly acknowledged and said that you want it. There's no magic in here. That is in every of your services.yaml file. And you can also use this lovely bind thing. And the bind is mostly to be used for parameters, as in string parameters. For example, an API key. You've got an API key variable as the constructor of whatever service, and how you can inject this API key in sort of like automated way from an environment variable, then you can actually do this kind of bind. So you could bind $API key, column env API key something. And we can hijack that as well to inject the right service based on the parameter name. So it actually means if you do that, and if you've got something like this, it is going to work. Yeah? So you are going to be able to inject multiple instances with the same interface, but different buses. I hope I didn't lose like many of you here. That's it for the different message buses. Even though that makes me think about a very interesting slide that I didn't write. Makes me think that actually, if we want to register, so we've got multiple buses. When we actually create a message handler, it does actually sort of like listen to all the different buses by default. So there is actually a 4th way that you can define your message handler. I have to admit, I'm still waiting for the slide to come up. So there's a 4th way that you can actually do to say, I want to register this handler for this message, but actually you can actually say multiple things on top of that. You can say it's going to be only for this bus, as you can see on the top left here. So you can actually say, yay, that one. So on top of the message handler interface, we have a message subscriber interface, which actually extends the message handler interface. That one is interesting. It very looks like the event subscriber interface for the event dispatcher, if you may have seen that one. It allows you to, for one given subscriber, to subscribe to multiple messages, plus to have some custom sort of like configuration. So that one here, you're going to say, okay, that's the slide after, but that's okay. We're gonna work with that one. You can actually say that this message is going to be listened for only the first bus. And the second one is actually saying this message, my message class, is going to also be listened for the second bus. So the reason it is another slide than the one that was supposed to be here is because that's the reason, that's the explanation of why we use yield rather than an array. All this like event subscriber interface and all of that, they use actually return an array, so you can say the name of the event and what's going to happen. In here, you can actually yield multiple times the same key. So you can actually say this message X that actually needs to be dispatched in 2 different buses. I'm going to just listen for these ones. And you can also say, here we go. You can also say, oh, actually, I'm going to, instead of calling the default invoke method, you can actually call different methods within the same subscriber for different messages. So that's how you can go very deeply in what you configure, very deeply in what the handler is actually listening to, and which buses. I promise that's the last option of how you register an handler. The next bit is middlewares. So I've mentioned at the very beginning that the bus itself is completely stupid. It does merely nothing. The entire behavior and the entire logic come from middlewares. So middlewares, they look like something, they are a class that implements a middleware interface, which is basically going to be, every single middleware, when you dispatch a message to a bus, is going to be called. And it can do stuff before and after the message is actually handled. OK? So an example might be that you want to create your own middleware that is going to be an audit middleware. The common use case is saying, every time I actually dispatch a command, at the beginning, the command is actually handled, or this my handler is actually fired. And after, I want to just display some logs and say, hey, I've started to handle this message, or I finished to handle this message. What you can do is to create your own middleware to do this exact same thing. So I'm going to try to describe it to you because you cannot see it. So it's a class that implements the middleware interface that has just one method. That method is called handle, and it has 2 parameters. The first one is a message parameter, and the second one is a callable, which is next. So what you're going to have to do in your middleware is to say, you can actually call the next callable with the given message to call the next middleware. So a middleware is just aware of its own little scope, and its own job is to call the next middleware. So it actually means in this example, the audit middleware I mentioned, you can actually say before the next middleware is called, and therefore before your actual message handler is called, you can actually say, hey, I'm going to display started with message X. And you can use this sort of like trick of like the try and finally to directly return the result of the next middleware. But just before you actually return, you can actually print, yeah, I've finished with this message. Does that make sense? Nice. So the way you can configure your middleware is in the same configuration file. For every, so the config, compared to the handler, where you can actually define using tags and all of that, the middlewares, because they add a very potentially complex and different like logic to the entire way of the bus behaves, you need to configure it per bus and explicitly in the configuration. So that looks like something like that. So we're going to say that for the common bus, we're going to have our new middleware, app middleware, audit middleware. And it's going to be used. That's it. So there's no plural to middleware. That's why there's no S, but that's a collection. So you can have as many middlewares as you want, and they are going to be run in the actual order you define them. Yeah? So that's it. You've added that. You just you dispatch your message, and you're going to have these beautiful audit logs on your screen. Or ideally, you want to log them somewhere better than on your screen. The last concept, and that one is probably one of the most powerful feature, I believe, of the Messenger component that Maxime created. So it's called the envelopes. And the idea is to use the same thing that messages, right? The sort of like a metaphor saying we send messages to whoever, and then we wrap them into envelopes to just put the address and put all this kind of stuff. There's a lot of sort of infrastructure-related thing. So it can be actually your stamp, it can be the address, whatever, the return address, all this kind of stuff, when you send a message. The same concept can actually apply to our messages, because we've taken the approach of saying the message you dispatch to the bus are really your own domain message. We needed a way to add something on top of that. And that's the envelope. So every single message, when going through transports and all of that, is wrapped into this envelope. And it turns out this envelope has different items. So you can actually add some infrastructure-related information on all your messages. For example, there is a potential problem that maybe some of you actually got when I described the principle of the worker pulls the message from the transport and then dispatches back to the message bus that calls to the handler. But actually, my worker gets my message, dispatches it to the bus, and I'm expected to have the handler to be directly called. But I've configured the message bus to route this message to the transport, right? So in theory, that should actually just do a very weird loop. Because when the worker pushes back to the actual message bus, the message bus says, yeah, I need to route it, and et cetera, et cetera. So using this envelope, there are multiple things. So the way, first of all, we can use the envelope is by, on top of the middleware interface, there's a small trick that you can also add. You can see here, you add a second interface that says, I am envelope-aware interface. That means that your actual handle function will not get your actual domain message. It will get your envelope, which is an object which has a set of properties, including get message, from which you can get your actual domain message. But it has this notion of items. And typically, inside the core of the Symfony Messenger component, there is one item that is very useful for us. And it's called received message. So that's an item that's added to the envelope when the worker actually pulls the message from the transport, and it says, yeah, I'm going to add this item, received message. So then, when the middleware who's responsible for actually sending the message to the actual transport, instead of calling the handler, when it sees this item, it says, oh, OK, I just got the message from the queue. I will not reroute it again. And that's it. So we've got much more information around the actual message. You can also create your own envelope items. So I'm going to reuse the example of the audit middleware. Turns out that when you dispatch a message to your bus, let's say you've got a log that says, well, you know, I'm like starting to handle this message, or I'm starting to consume this message. I don't know exactly which slide is which one anymore. But that's the example that I can show you using the received message. So you can say, if I have an item from the received message type, then it means I just consumed it. So in my audit log, I can actually change the message. If I don't have it, it actually means I've just dispatched it. That's the trick. Now, you can create your own, oh, it changed too much. You can create your own audit envelope item. And the use case that I mentioned was, really, you've got all this log that's fantastic, but you don't really know how to match the two different log files, right? So you've got some logs that says this message has started to be, has just been dispatched, and you've got somewhere else this message of this type has been consumed. But what you want is to have a sort of like a correlation identifier. Or you want something that's much more related to your logs onto your actual infrastructure to be able to match the both. And that's where you are going to use, you can create your own custom envelope item. So this example is your own, you created the audit envelope item. That's your own item. I'm going to show you just later what an item is, but again, it's just a PHP class. So here where you can see in this audit middleware now, you can see the first bit being like, OK, right, if I don't have an audit envelope item, if I don't have one, I am going to override the envelope with a new envelope with a new item on the envelope. And this item is the audit envelope item that actually generated a unique identifier on the fly. So there's a bit of magic of like assignments in the ifs and in these different things, but it makes the code much shorter for the slides, and also it means that on the rest of the code, we can use the audit envelope variable to get the envelope, whether the envelope item, whether we actually created it or we just retrieved it from the actual envelope. Therefore, what it means is that here I can add at the beginning of my actual log, I can ask the audit envelope item, get me the UID, right? So what it means, I'm going to dispatch the message from my web or the HTTP request that triggered this thing. I'm going to generate an ID. I'm going to slightly change the envelope. It is going to be sent to my transport. That envelope item will still be around. And then when I consume the message, the envelope item will still be around, and therefore the ID here will be the exact same ID than the message I've generated when I dispatched the message. And you can put a lot of information. There's a lot of, as soon as we start to do asynchronous things, there are a lot of informations like that you may want to put that are not part of your actual domain. Typically, it can be security contexts of which user did actually trigger this information. That might not make real sense in your actual object or in your actual command or query, but it would actually make sense for the infrastructure to be able to reconstitute the context of your application when you are in the worker, right? I find it very, very interesting, but I'm a bit biased. Your own item looks like this. It is just a class, nothing fancy, with a marker interface that says it is actually an envelope item interface. And that's it. Obviously, that needs to be serializable as well. Now, you can also use the envelope for a different type of usage. So you can use it to transfer information, but you can also use, for example, to configure the serialization groups that are going to be used when the message is dispatched and sent to the transport. Very likely in the next Symfony release, we are going to have these kind of envelope items to be used for, do I actually want to dispatch the message in the same doctrine transaction or a different one? All these things are really much more on the infrastructure side than on the domain, can actually go in these actual envelope items. Yeah? So a last note on the transport themselves. So there is a built-in AMQP transport that we shipped from the version 4.1. It is fully extensible in the way that you can extremely easily create your own transport. The only thing you're going to have to do is to create a class that implements the transport factory interface, put it somewhere in your code, and that's it, and do the implementation. And that way, you can actually use your own custom DSN to store it the way you want. It turns out that there is a very, very good PHP library. It is called ASYNCHRONOUS that is at least very good in terms of support. So they support, I think it's 12 or something buses. So it's the doctrine debug for message queue and all these kind of things. So if you want to deploy to push your messages to Kafka, or if you want to push them to Google, PubSub, all this kind of stuff, they've got you covered, and there is an adapter or a transport to use ASYNCHRONOUS within Messenger. So you can already use multitudes of transports. And the last bit is what can you do about it? So now you can try it. It's still experimental in 4.1. It is going to be a stable API, so which means covered by the backward compatibility policy in 4.2, which is going to be released in a few days or so. You're going to help us to make it great. It's the very beginning of what we can do with it. We've seen from Fabstock that it can actually be even better than just a message bus that sends things to some queues. Issues, pull requests, documentation, everything is welcome. And then enjoy it. And on that, thank you very much. Let's not ask. Any question? Yeah, sure. I'm not sure. Do we have a mic? Yeah, we do. Sorry, she's kind of. Hey. Here.
Sorry. I'm small, I can't see you. Sorry, Samuel. I have 4 questions.
Wow.
First one is, if we are setting up different buses, how can I run a specific bus? I guess that we need to add some kind of argument.
What do you mean by run? Is that when you want to dispatch to a specific bus?
Yeah, basically when we were queuing all these asynchronous messages, you were running a Symfony command.
Correct.
To run all those messages that were queued.
Yeah.
So I guess that we need to set up a specific argument or a specific
exactly.
option.
It's a specific argument, so you actually have 2 of them. You've got so by default, if you got one transport, one queue, one transport, one bus, it's super easy. Just use them as default, etc. But if you've got multiple transport and or multiple buses, you're gonna have to give them as an argument of the actual consume message command.
Okay.
Let's do 2 questions because we're already run out of time, and then we can give the mic to somebody else, and we can talk about it later. Okay?
Sure. And basically, if you're running an environment with multiple servers, how can you manage all messages? Because each server may be queuing some specific items. So maybe you have another server that is basically catching everything and then processing all these processes or tasks.
So when you've got multiple like front-end servers, you mean like multiple machines that run your actual website when you dispatch messages? Yeah. So you are going to put it to a queue system, right? A RabbitMq running somewhere, or even a database. These systems, the database using the transactions, or the RabbitMq using its own sort of like transactional technical details, will be responsible of giving it to only one, at least most of the time, to only one of the consumers. So it actually means we've got a multiple worker, you're going to start a bin console consume message multiple times as well, right? The message bus, or the queue system, is going to be responsible of giving that to just one consumer. That's sort of like a random thing.
Okay.
Yeah? Any other question?
Your worker example showed using a bin console command. PHP is not great at long-running commands. How do you deal with that?
It's not so bad. It's not so bad, and to be fair, the reason it is not necessarily ideal is because most of the libraries, they just create objects and keep everything in memory. I'm thinking Doctrine, I'm thinking SwiftMailer, I'm thinking all of these ones. Turns out from Symfony 4.1, and we even started before, there's actually a new kernel event, which is like for reset, which is actually fired almost all the time at the end of the request to recollect all these sort of like things in memory. There's also a library, it's called long running, which basically set up a lot of listeners for a lot of different libraries to like flush all of that. With that in mind, it's almost as if you don't leak memory, and therefore it stays more or less performant. There are, though, some arguments on the consume message command that you can actually say it can consume a maximum of X messages, and it can actually auto shut down after it actually uses X amount of memory. And then you actually expect that on the infrastructure side, whoever runs the command has a supervisor D or systemd or something like that to restart the thing. That's it. We don't have at all any time, so thank you very much again.